The Java Iterable interface represents a collection of objects which can be iterated. It is important to note that the Iterable interface is not the same as the Iterator interface. The two interfaces are related but different. The way the Iterable interface is related to the Iterator interface is that an iterable is a source of an iterator. In other words, from an iterable, you can obtain an iterator. I have created a basic iterable example here on the screen. At first, I create a list, add 3 elements to it, and then notice that because the list interface is a sub-interface of collection, it extends the collection interface. And the collection interface extends the iterable interface. That means that I can actually cast the list to a collection, and I can cast the collection to an iterable. Now, I didn't have to go through these steps to get to the iterable. I could just have cast the list to an iterable directly, or just down here where I'm using it, I could have used the list directly. This would have worked too. Once I have an instance of an object that implements the iterable interface, I can iterate the elements of that iterable in 3 different ways. And there are actually more, but there are at least 3 common ways to do it. The first way is to use the built-in forEach loop in Java, right? So I write for, and then I declare a variable string element, and then colon, and then I write the name of the iterable. Now in this case, it's this iterable declared here, but I could have used the list as I just explained. You see, the compiler doesn't complain. Now what happens here is that for each element available in the iterable, for each iteration in the loop, each element in this iterable will be bound to this variable. So we will loop through this loop one time for each element in this iterable, and bind each element to this variable, and then we can act on this variable inside of this loop. That is the first way. The second way is to simply call the iterable.Iterator method, which returns a standard iterator. And once we have an iterator, we can iterate it through using a standard while loop, where we call while iterator has next in a loop, and inside of this while loop, we call the iterator next method to obtain each of the elements available in the iterator. And the third way to iterate through the elements of an iterable is to call the iterable.forEach method. And as a parameter to the forEach method, I have to pass a lambda expression, a Java lambda expression. And for each element in the iterable, this lambda expression gets called. And the each element will be passed as parameter to the lambda expression. And that means inside this lambda expression body here, I can operate on this element. Now, as you can see down here at the bottom, it is also possible to obtain a Spliterator from an iterable. And a Spliterator is another component which can be used to iterate the elements of an iterable, but I will not cover the Spliterator in more detail in this video. Now you know it exists, you can go and find information about it yourself. There are actually several interfaces and classes in Java which implement the iterable interface. Now you can see here I used list, which is an interface itself which extends the iterable interface. But the same is true of a set, right? A set, now I need to use a hash set instead here. Now, as you can see, I haven't changed the variable name, that doesn't matter, but you can see since set also extends the collection interface and collection extends the iterable interface, you can actually also iterate the elements of a set with the standard Java forEach loop, or you can obtain an iterator, or you can call the iterable.forEach on it. Let's just quickly have a look at the iterable interface definition. It's actually quite simple, and then later we will have a look at how to implement the iterable interface yourself so that you can make your own collection classes iterable with the standard Java forEach loop. But first, let's have a look at the iterable interface. I will just open up the interface definition. Now, never mind all the green text out here, all the comments, right? So iterable has a method here called Iterator. It has a method called forEach. We have already seen that in use. And then it has the Spliterator method, which we have also seen in use already. Notice that the Spliterator method and the forEach method are default methods, which means A, you can actually have code in them, which is normally not possible in an interface. And B, you do not actually have to implement these two methods when you implement the iterable interface. If you do not override these methods, do not implement these forEach and the Spliterator method, your implementation inherits the default implementation found in the iterable interface. Now, let's have a look at an implementation of the iterable interface. As you can see, it is just a regular Java class which is declared to implement the iterable interface, and with the generic type string, so that you can iterate string elements contained inside of this iterable impl object. Now, internally, the iterable impl class here just keeps its elements in a standard list. You are free to choose how you want to keep your elements internally inside such an iterable implementation, but I've just used a list here for the sake of making the example simpler. And you can see this method here, this add method, is also just adding the element directly to the list internally. Okay, this add method is not a method you have to add or implement. It's not part of the iterable interface. I've just done that so that later when I show you how to use this class, it is easy to add elements to it. Now, the iterable interface requires that you implement this method called Iterator, and there are actually a few mistakes here, right? First of all, the generic type should be string, because I have declared up here that the class is implementing the iterable interface with a generic type string. So the iterator returned should have the same generic type. Second, I should not call this .iterator, but of course this .elements.iterator, right? Now it is correct. Now let's have a look at how it looks when we use this iterable impl class. I have prepared an example here. First, we create an instance of this iterable impl, which I have just showed you the implementation of. Then add two elements to it, which will be stored in the list internally, kept internally in the iterable impl. And then we can use the iterable inside of a standard Java forEach loop. Each of these elements added here will be bound to this element variable for each iteration in the loop. Now let's run this example and see that that is actually true. As you can see, the code prints out these elements, and as you can see, we get printed out 1 and 2, which were the elements added up here. So you can see the iteration of the elements in my iterable impl works. Obviously, I could also obtain an iterator from my iterable, right? Because after all, I have just implemented this method in my iterable implementation. Now I could iterate through this iterator with a standard while loop. I can also obtain a Spliterator from the from my iterable implementation, because even though my implementation does not explicitly implement the Spliterator method, the iterable interface comes with a default implementation of the Spliterator method, which I then inherit. My iterable implementation inherits that default implementation. And the same is true for the forEach method. That is also inherited from the default implementation found in the iterable interface, even though my implementation does not explicitly implement this method. So I can call it pass a lambda expression to it, which will get called for each element in the iterable, and then I can print out the element. Now let me just remove these two lines here, and let's try to run this example. And we expect, of course, to get two sets of printouts of the elements, like 1, 2 from the first iteration up here, and then again 1, 2 from the second iteration down here, which was triggered by the call to the forEach method. Finally, I just want to talk a little bit about the iterable performance. And if you look at this example here, I create a list, I add 2 elements to it, and then I iterate it with the standard forEach loop, right? I iterate through all the elements. Now, what actually goes on behind the scenes is this down here, right? So an iterator is obtained from the iterable, and then the iterable or the iterator is looped through with the standard while loop. Like, it doesn't look like that in your code, but that is actually what happens. Now, from a performance perspective, this is normally not a big problem, but if you are iterating through a list thousands of times per second, like I have done that sometimes 100,000 times per second, then for each time you need to iterate through the list, you are actually creating an iterator, which is a new object, right? So you are creating a lot of objects, a lot of iterator objects, which will put some pressure on the internal memory management in Java, plus as well the garbage collector. Now, so if you really need maximum performance, you can use a standard for loop, as I have shown you here, right? You start by creating a variable, index variable called I, set it to 0, then another, like a boundary variable called list, or called n, which is set to the size of the list, and then we iterate, on as long as I is less than n, as long as I is less than the size of the list, we increment I, right? And then inside of this loop, I can obtain each element in the list by calling list.getI. Now, this is actually slightly faster than these two loops up here, if you really need to get that last bit of performance out of your loop, of your iteration. But in most cases, you won't need it. Now, obviously, this iteration here only works for lists. You would not be able to use this iteration with a set or a map because these two classes or interfaces do not have a get method where you can get an object based on its index. So it only works for lists, but in case you need performance while iterating a list, you can use this loop instead. That pretty much covers what you need to know about the Java Iterable interface in order to start using it. Remember to check out the description below the video, because I have a link to a textual version of this tutorial as well as other related tutorials. And if you like this video, hit the like button and maybe subscribe to this channel as well in case you want to watch more videos like this one.